recreating a strange visual effect predicted by Einstein's theory of special relativity. Using ultra-fast lasers and precision cameras, scientists at the Vienna University of Technology simulated what objects would look like at near-light speeds without actually moving them. The effect they recreated is known as the Terrell-Penrose effect, a visual illusion where fast-moving objects appear rotated, not squashed, as they approach light speed. While physics predicts that such objects shrink along the direction of motion, a phenomenon called Lorentz contraction, this optical trick occurs because light from different parts of an object reaches your eyes or camera at slightly different times, creating a warped snapshot. This illusion, first described in 1959, had been theorized and modeled before, but this is the first time anyone has recreated it in a lab using physical objects. Since it's impossible to move something like a cube or sphere anywhere near the speed of light, the team used a clever workaround. They placed a cube and a sphere in a lab and fired ultra-short laser pulses, each lasting just 300 picoseconds, at the object. After each pulse, they moved the object a tiny amount, then repeated the process. Each pulse captured a thin slice of light bouncing off the object, and when all the slices were combined, the final image showed what it would look like if the object had been moving at incredible speed. The objects appeared rotated, just as predicted, though they never actually move. It's a visual illusion caused by how light travels. An Earth-sized planet called Planet Y could be hiding in our solar system, according to a new theory, and it's much closer than Planet 9, also known as Planet X. Proposed by researchers in a recent study, Planet Y is a new candidate for the elusive ninth planet, theorized to reside in the Kuiper Belt and potentially just 100 to 200 times farther from the Sun than Earth. This is a significantly shorter distance than the estimated orbit of Planet X, which is believed to be 400 times that distance or more. Unlike the gas giant qualities attributed to Planet X, Planet Y is thought to be rocky and Earth-sized, or slightly smaller, possibly falling somewhere between Earth and Mercury in mass. The theory comes from an analysis of the tilted orbits of 50 Kuiper Belt objects, which are inclined about 15 degrees from the typical orbital plane of the solar system. The study's lead author, Amir Siraj from Princeton, said that while this isn't a direct discovery of a planet, the orbital anomalies suggest a hidden world is the most likely explanation. Still, this theory remains speculative and faces skepticism. Critics argue the findings are based on too small a sample and require much more supporting data. Planet Y doesn't replace Planet X in theory, but adds a new possibility, potentially increasing the solar system's planet count to 10 if both exist. Detecting such objects is challenging due to their faint light reflections and tilted orbits, but upcoming observations from the Vera Rubin Observatory may soon provide answers. The observatory, equipped with the largest digital camera in the world, is expected to uncover thousands more Kuiper Belt objects in the next few years. Dark matter and dark energy may just be a cosmic illusion. The mysterious forces scientists have long believed make up most of the universe might not actually exist. Instead, according to new research from the University of Ottawa, what we're seeing could simply be the result of natural forces like gravity, slowly changing over time as the universe ages. This theory challenges decades of thinking by suggesting that the universe's strange behaviors, like galaxies spinning faster than expected and the universe expanding at an increasing rate, can be explained without needing to invent invisible stuff like dark matter or dark energy. Researchers argue that if the fundamental forces of nature gradually weaken over time, it could create the illusion of extra gravity, which we call dark matter, or an unexplained outward push, which we refer to as dark energy. Instead of needing two separate explanations for what's happening on large and small scales, this theory uses a single, consistent equation. At the heart of this new model is a parameter called alpha, which behaves like an extra factor in gravity equations. On the cosmic scale, alpha acts like a constant, but on the local scale, within galaxies, where matter is unevenly spread, it shifts depending on how much normal matter is present. This varying alpha produces effects similar to the gravitational pull we previously blamed on dark matter. It also helps explain the flat rotation curves of galaxies, where stars far from the center are moving faster than expected. In short, the new model doesn't need dark matter halos to explain galaxy motion. The extra gravity comes from how alpha behaves.